Welcome to this lecture on configuring Visual Studio Code with Cline for better secure coding output. In this session, we'll focus on how AI-assisted tooling can support safer, more resilient C and C++ development when it's set up thoughtfully. The goal is not just to generate code faster, but to guide the tool toward producing output that aligns with secure development practices, real-world reliability, and stronger engineering standards. In this lecture, we'll follow a clear four-part roadmap. First, we'll cover the fundamentals of VSCode and Cline, including what Cline is, how it fits into the editor, and why it's useful for secure C and C++ development. Next, we'll move into setup and extensions. That includes installing the compiler toolchain, configuring the C and C++ extension pack, and getting Cline connected properly with the required API keys. From there, we'll focus on secure configurations. We'll look at hardening flags, editor task, and launch settings, and how to tune the model for more consistent and predictable output. Finally, we'll wrap up with practical examples and next steps using realistic scenarios such as fixing buffer overflows, generating unit tests, and supporting SCI and CD workflows. Cline is an open source extension for Visual Studio Code that brings powerful AI assistance directly into the development workflow. It can work with models like Claude 3.5 Sonnet to help with coding, debugging, and security auditing in a much more automated way. One of its biggest strengths is security review. Cline can scan large amounts of code very quickly and flag issues such as SQL injection, memory leaks, and use after free bugs while you work. That makes it useful not just for finding problems faster, but for catching them earlier. It also helps generate code with security in mind. Instead of producing generic snippets, it can create secure by default examples that align with OWASP guidance for C and C++ development. And as a debugging partner, Cline can explain seg faults, interpret stack traces, and suggest targeted fixes based on the code in front of it. So rather than acting like the simple code generator, it functions more like an intelligent assistant for writing safer and more reliable software. Secure coding matters because many of the most serious C and C++ vulnerabilities come from a small set of recurring memory and arithmetic errors. Buffer overflows, use after free bugs, and integer overflows continue to appear in critical C VS year after year, which is why they map directly to well-known weakness categories like CE119, CE416, and CE190. The good news is that these risks can be reduced significantly with disciplined secure coding practices. Input validation, bounds checking, and safer string handling help prevent entire classes of defects before they reach production. When you combine those practices with AI-assisted review in Cline, you get another layer of protection. Cline helps automate OWASP top 10 style risk reviews for C and C++, making it easier to catch issues that manual inspection can miss before deployment. Before working with secure C and C++ in VSCode, make sure the environment is set up correctly. First, install the latest stable version of Visual Studio Code and verify that it's available in your system path. Next, add Microsoft C and C++ extension pack. This gives you core features like IntelliSense, debugging support, and compiler integration. You'll also need compiler. On Windows, common option is MingWeb through MSys, or you can use MAC from the Visual Studio build tools. After installation, confirm everything is working by running g++ -- version. Finally, configure your environment variables so VSCode can consistently detect the compiler toolchain across projects. Setting the compiler path in settings.json helps avoid setup issues later and makes the development experience much smoother. To install and configure Cline in VSCode, start by opening the extensions view with Ctrl+Shift+X, search for Cline, and install it. Next, create an Anthropic account. If you do not already have one, copy your API key and paste it into the Cline API key setting from the VSCode settings search. After that, select the Claude 3.5 Sonnet model. This gives you a strong balance of speed, reliability, and secure code generation. For a more controlled setup, update your settings, JSON with the model name, a max token value of 4096, and a temperature of 0.2. That lower temperature is important because it reduces randomness and helps produce more consistent, predictable, security-focused output. These core extensions turn VSCode into a much stronger environment for secure C and C++ development. The Microsoft C and C++ extension gives you IntelliSense, build support, and debugging, while also helping catch issues like memory misuse as you work. Cline adds AI-assisted review and code generation, which is especially useful for identifying common buffer-related weaknesses automatically. Error Lens makes problems much more visible by highlighting them inline, so security-relevant issues stand out immediately instead of getting buried in the problems panel. GitLens adds important traceability by showing commit history and blame information, which helps when auditing changes and spotting security regressions. Even something simple like code spell checker has security value. Typos in variable names, constants, or function calls can introduce subtle logic flaws, so catching naming mistakes early matters. A good practice here is to pin these extensions to your workspace profile so your secure coding setup stays consistent across projects. Also make sure the CCPP default include path is configured to include secure headers such as secure H. Here, we're hardening the toolchain by adding security-focused compiler flags in tasks, JSON. This gives VSCode secure build task that helps catch problems early and adds runtime protection. The build command uses G++ with few important flags. Wall and Wex return on broad set warnings, which is useful for spotting risky code patterns and subtle bugs before they become vulnerabilities. The F-stack protector strong flag adds stack canaries. These help detect stack smashing attempts at runtime, which is especially important in C and C++ code that works closely with memory. The defortify source equals 2 setting enables additional checks in glib for common functions like CI and mempb that can help detect buffer overflows when the compiler has enough information about buffer sizes. Together, these facts create stronger default build configuration. Instead of relying only on code review, you're also using the compiler and runtime to enforce safer behavior. Here's a simple workflow for using Cline to generate more secure C code in VSCode. Start by opening the C file you want to work on, then go to the Cline sidebar and enter security-focused prompt. The key is to be specific. For example, you might ask Cline to generate secure string copy function that avoids use IA. Once Cline produces code, review the generated diff carefully before accepting it. In this example, the function URI lists a copy to the destination buffer size -1 and explicitly adds null terminator. That final step is important because it helps prevent unterminated strings. You can also improve consistency by adding custom instruction in client settings, such as always use secure functions and check for OSC and C++ risks. That helps guide the AI toward safer code generation every time. Here are some pro practices for getting the most out of Cline and VSCode together. First, focus on prompt engineering. Use targeted prompts that clearly state the security issue you want reviewed, such as buffer overflows or race conditions, and ask for suggested fixes. This helps Cline return more useful annotated diffs instead of broad, less actionable output. For faster day-to-day work, automate reviews inside VSCode. You can bind the review selection command too. A shortcut so any highlighted snippet can be checked instantly. That makes security review lightweight enough to use continuously while coding. Version control is also important. A strong practice is to commit AI-generated suggestions to dedicated AI review branches. That gives you traceability, makes team review easier, and keeps AI-assisted changes separate until they are verified. Finally, bring this into SICK. By using the Cline API in GitHub Actions, you can run automated security scans on every pull request. That adds consistency and helps catch issues early before code is merged. Here are some of the most common security pitfalls to avoid in day-to-day development. First, never hardcode secrets. API keys, passwords, and tokens should not live in source code, even in private repositories. Use environment variables or a dedicated secrets manager so sensitive data stays outside the codebase. Another major issue is unsafe input functions. In C and C-like languages, functions such as gets and EA can easily lead to buffer overflows. Safer alternatives like fix ARC or RIA help enforce limits and reduce that risk. You also want to avoid skipping input validation. Any external input, whether it comes from a user, the network, or a file, should be validated and sanitized before your application processes it. Trusting raw input is one of the fastest ways to introduce vulnerabilities. And finally, do not ignore compiler warnings. Flags like wall and Wextra are there for a reason. During development, it's good practice to treat warnings as errors because many real security issues first show up as compiler warnings. Here's a simple real-world example of how buffer overflow gets introduced and how to fix it safely. The vulnerable line is SIA to copy user input into buffer with no bounds checking at all. That means if the input is larger than the destination, the program can overwrite memory, leading to crashes, corrupted data, or exploitable security flaws. Secure replacement URI with it the size of the destination buffer. That makes the copy length aware and helps ensure the buffer is not overrun. Another good option is seprint, which also respects the buffer size while writing the string. The key idea is that secure code never assumes input will fit. By adding explicit size limits, tools like Cline can automatically transform risky code into safer patterns that prevent stack or heap smashing. Here's another real-world case. Secure an HTTP header parser in C. When web server accepts header input, it has to treat that data as untrusted. If it doesn't, attackers may URF injection, header splitting, or oversized values that lead to truncation bugs. In this example, Cline generates safer pattern using smprint. The important detail is that the code checks the return value. If the return value is greater than or equal to the destination buffer size, that means truncation happened. Instead of silently continuing, the code logs the issue and rejects the header. That gives us 3 security benefits. First, it helps prevent injection by treating suspicious header content carefully. Second, it catches truncation before it turns into hidden parsing problem. And third, it uses an explicit error path, which is critical in secure C code. When input is invalid, the program fails safely instead of guessing, ignoring the problem, or leaving behavior undefined. In multi-file projects, security settings need to be applied consistently across the whole build, not just in a single source file. That's where CMake integration becomes especially useful. Cline can read and update your CMake's TXT file to add hardening and sanitizer flags automatically for your targets. In this example, target compile options enables address sanitizer, undefined behavior sanitizer, strong stack protection, and fortify source. This helps detect runtime memory issues such as heap or stack buffer overflows and use after-free bugs. Upson catches undefined behavior, including signed integer overflow null dereferences and misaligned memory access. The key benefit here is scale. Instead of manually configuring each file or target, you can enforce these protections across the project through the build system, which makes secure compilation much easier to maintain. This slide shows a practical debugging workflow that combines address sanitizer with Cline. The idea is to enable a summary in your launch configuration so every debug session checks for memory safety problems automatically. That includes issues like invalid memory access, heap corruption, and use after free errors that might otherwise only show up as vague crashes or intermittent seg faults in the launch. JSON example we define. A debug configuration named debug with a UVGE. With this setup, you can run the program under the debugger and get much more precise diagnostics when something goes wrong. A useful part of this workflow is what happens after the crash. When you hit a seg fault, take the stack trace and give it to Cline with a prompt like explain this seg fault and suggest a fix. Cline can help interpret the trace, identify the likely root cause, and suggest a safer implementation. This makes debugging faster and more focused, especially in C and C++ code where memory bugs can be difficult to trace manually. For quality assurance, AI-generated unit tests are especially useful for covering edge cases that are easy to miss by hand. The process starts by building securely with hardening flags enabled in tasks, JSON, so the code is compiled with stronger protections from the start. Next, prompt Cline to generate tests for the cases that matter most in C and C++, such as null inputs, maximum buffer sizes, and empty strings. These are exactly the kinds of conditions where subtle but serious bugs often appear. Once the tests are created, run them in the VSCode test runner or through a C-test setup. Then review the results carefully and refine the prompt based on any failures or gaps in coverage. When the tests are solid and passing, add them to your security regression suite so those edge cases stay protected over time. These key metrics show why Cline is so effective for secure code review. First, review speed. At more than 1,000 lines per minute, Cline can inspect code far faster than a manual audit, which makes it especially useful when you need quick feedback across large code bases. Second, temperature. A setting of 0.2 keeps the output focused and consistent. That lower randomness is important in security work, where you want reliable, repeatable results instead of creative variation. Third, max tokens. With a context window of 4,096 tokens, Cline can evaluate full functions and return safer, more complete writes rather than isolated suggestions. And finally, coverage. Checking against more than 10 OWASP risk areas helps ensure the review is aligned with recognized vulnerability categories in C and C++. Taken together, these numbers highlight the real advantage: faster reviews, more consistent output, enough context for meaningful fixes, and broader security coverage. To keep building your skills, the best next step is hands-on practice. Fork and experiment with a public security repository from GitHub, then use Cline to refactor parts of it. That gives you a practical way to learn the workflow by doing. A strong reference to keep nearby is the OSC Secure Coding Guide. It's a reliable source for secure C and C++ practices, and it can also help you write better prompt templates for your team so Cline produces more focused and useful results. You should also spend time with the official VSCode C++ documentation. It covers advanced IntelliSense, remote development, and CMake tools integration, which can make your environment much more effective for secure development work. One practical tip is to monitor your Cline API token usage in the Anthropic dashboard. Shorter, more targeted prompts usually cost less and often produce more precise output. The key takeaways are straightforward. First, configure first. A secure C or C++ workflow starts with the right foundation, including compiler, flags, build tasks, and sanitizers. Next, prompt precisely. When you give Cline clear, security-focused instructions, you get more consistent and auditable results. Keeping the temperature low also helps produce reliable output. Integrate early as well. Bringing Cline into your SIG pipeline and Git workflow helps identify vulnerabilities before they make it into production. And finally, keep learning. The best results come from combining Cline with established secure coding guidance, OS recommendations, and compiler documentation so your security practice continues to improve. You now have the full toolkit. A hardened versus code environment, Cline configured with security in mind, and practical workflows that help you catch vulnerabilities before they turn into real exploits. The goal is simple: build secure software and ship with confidence. As you continue applying these practices, the VSCode C and C++ documentation is a great reference for editor setup and language support. The OS secure coding resources can help reinforce secure development habits, and the Cline GitHub repository is the place to explore updates, examples, and community guidance. Go build something safe.